Okay, so question 6E4 from Statistical Rethinking, second edition. And this is the last of the easy questions. And here is the question right here. So how is a biased sample like conditioning on a collider? Let me say that a little bit differently. I feel like that was a little confusing, even though that's verbatim. So how is a biased sample similar to conditioning on a collider? Okay, and we're meant to relate this to the example at the beginning of the chapter, and I'll go over that here in a minute. So first, let's talk a little bit about what colliders are. So in the previous question, recall that colliders, right here, colliders are where some variable, I call it C, this calls it Z, where some variable is an effect of two other variables, right? In this case, X and Y. Okay, and the interesting thing about colliders is as opposed to the other two motifs, forks and mediators, in which X and Y begin as being dependent, that there's an association between X and Y, and that association is only broken after conditioning on the middle variable, the fork or the mediator variable. Okay, colliders start out where X and Y are independent, and then become dependent when conditioning on the middle variable, C. Okay, so that's what colliders are. I want to start by trying to, I think that this relationship in colliders can be a little bit confusing, and there is an example by Judea Pearl, who is kind of a pioneer of this way of thinking, one of the pioneers. And here, and in the question above, there's a great short book by him that goes into some of this stuff in a little bit more depth. But there's an example that he gives that for me was very illuminating. So imagine that we have two variables, X and Y. Okay, and now these variables for us are going to be two different coins that I'm flipping at the same time. Okay, X is a coin, Y is a coin, and we're just going to go down and we're going to write heads, tails, okay, for both of these coins. Now, what do you imagine? So let's say we do this 1,000 times. What do you imagine will be the relationship between X and Y? Well, there should be no relationship, we would guess, if these are fair coins. And well, anyway, there should be no relationship between them, right? They're two separate events that are just kind of putting out their data kind of this haphazard fashion. But now let's consider a third variable, and we'll call it C. Now C is a bell that rings, and it rings at a very particular point. It rings whenever both X and Y land on heads up. Okay? So now let's go through so now we have a data set that has 1,000 different entries for variables X, C, and Y. And we're just going to go through that data set, and we're just going to select the values of C where the bell rang. Now think about what the relationship between X and Y is going to be. Well, now they're going to be highly related because we have selected cases where X and Y both happen to be heads. And so they're going to be very related if we select on C. So when we've only selected data where the bell rings, this is the same, this is a collider. We have, by only using that data, we are conditioning then on C. Okay, so having said that, let's move now to the example at the beginning of the chapter and talk about how some of this maps onto that. Okay, so the example at the beginning of the chapter was, it's represented here in figure 6.1, but we have a bunch of proposals for funding, right? So when scientists want to do some research, they need money. And the way that they do that is they often apply for grants, and some committee has to look through those grants and determine which ones should have money. And the idea here is that at least two of the criteria is the trust that determine if the study or if the researchers get funded is the trustworthiness of their proposal, as well as the newsworthiness of that proposal. Okay, and so these are two things that are affecting the selection. Okay, so we can think then of trustworthiness and newsworthiness as being something like X and Y, and whether or not they get funded as being something like C here. Okay, so let's say that you and I want to analyze how trustworthy published research is. Okay, and we think that there's a relationship between the newsworthiness and the trustworthiness of it. Okay, so here I have T for trustworthiness, and I'm going to regress it on an alpha as well as newsworthiness. Okay, so this regression is implying a DAG that looks like this, that n affects T. Okay, but the actual DAG, the actual causal structure behind this would be, although we might not know it, but the actual structure is that N causes P, where P is a publication is produced. Okay, and T, trustworthiness, also determines if a publication is produced. Now, just to make sure that you're not interposing different terms here, P is a published study. Something gets published. Okay, the data up here was representing funding, but only funded studies get published. Okay, that's the important part here. Okay, only published studies get or only funded studies get published. Okay, so now think about what would happen if we included P in our regression. It would look, so here would be the new regression, but we would be regressing on P, and therefore we would be conditioning on a collider, right? And that's generally a no-no, because all of a sudden we are inducing an association between N and T here, okay? And that would mean then that in our regression, we would see that the beta term for N would be revealing some kind of association between T and N, okay? And we might mistakenly believe then, based on the outcome of that regression, we might mistakenly believe that newsworthiness is somehow causing trustworthiness, or right? And according to the data up here, the more newsworthy something is, in other words, the more attention grabbing, the less trustworthy it is. Okay. And so we think, oh well, it's a good thing that we're not including P published, whether or not the study was published. It's a good thing we're not including P, because we wouldn't want to make that faulty inference. But the problem is that we have already included P, even though it's not in our, so even here we've included P. Why? Because our data was only published studies. So P is an implicit term here already, right? Every study was already published, or yeah, the only data that we have is the published studies. Okay, and so we have inadvertently, by the way in which we collected data, only looking at published studies, we have inadvertently conditioned on a collider. And therefore, even this regression will show a relationship between T and N, even though if we were to consider the entire, instead of just the blue ones, so the blue ones are the published, but we're going to say it's the funded ones, but these ones go on to get published. And this was our data set was only the blue ones, but had we had access to all of the data, we would not find an association between T and N. Okay, so again, this is what we went through was a selection bias, but selection bias is like collider bias, okay? And we get the collider bias even without including the collider in the regression if our data has been collected in such a way that we have implicitly conditioned on a collider.